Hello, my name is Hirva Dandukya and I am a master's student at Dalhousie University. I am working with Persuasive Computing Lab to develop a project, GazeGuard, which is Attention-Aware Phishing Detection Web Extension. The problem with phishing attacks is that they exploit users' attention and trust. The existing tools that prevent the users from these phishing attacks, they solely rely on URLs or just static rules. Moreover, users often miss subtle phishing cues while reading content. Also, high false positives reduce the trust in security warnings. A new tool should be made which is focused on preventing these problems and giving the user a more reliable experience. The solution we are presenting is GazeGuard. It is a real-time phishing detection based on what users actually read. This persuasive-driven solution takes help from users' gaze, and the gaze-driven content is selected for focused analysis. The extension uses a multi-stage risk detection pipeline for its backend. It uses heuristics as well as AI. The technology stack and tools used in this extension are JavaScript. Authentication is used by Clerk. The eye tracking API that is used is WebGazer. OpenAI LLM API is used to give context-aware nudges. The backend is based on Node.js and Express. Database is used as MongoDB, and the browser APIs used are Chrome storage for local storage and caching, messaging, and web workers. Let us go through the system flow. After the installation and sign up of the Chrome extension, if the user is not yet signed up, the Clerk authentication takes the user's information, saves into MongoDB, which provides the user a dashboard access via which they can see if they have any history with the extension or not. If the extension is already enabled, a calibration is done where the points are mapped on the screen. If the calibration is complete, a risk detection pipeline will work in the background. Let us see through what are different steps in this pipeline, which makes sure that the correct phishing text is fetched from the system and a proper nudge is given to the user. So the WebGazer, that is the eye tracking API, works in the background. The DOM text extraction is done with attention-aware filtering. After that, a debounce and fixation validation is done, which helps us to not fetch too many information at once. All of the text that is fetched is hashed and saved in a local cache so that one text is not saved multiple times or used multiple times. All of this local cache is verified and a pre-scan is done via regex verification before calling the local LLM. Even the LLM call has a rate limiter to prevent from excessive calling to the LLM. All of the LLM response that are showed are sent in the UI and showed as a notification or a simple nudge, as we saw in the screenshot earlier. All the responses are saved in the database, which can be seen by the user with the dashboard. Let's go through the demo. I have started my extension. Let me upload the extension. User can access the GazeGuard via the Chrome extension out here. This is the home page for extension where it will ask you to sign in. If you have not signed up yet, you can create another account. Let us do that. The password also meets unnecessary requirements and checks to make sure that it is strong enough. After hitting the continue, it will ask me to verify it via email. A code will be sent via clerk. After verification of the code, I can enter the organization name if I want. After hitting the continue button, the extension will show me that the WebGazer is starting. This is the first nudge where the extension tells that we are using the camera and the calibration system can be started. This phase of the application is the calibration page where I am mapping different points on my screen so that I can help the extension to know where my eyes is looking at a particular point. The calibration is only done once when a user logs in to make sure that the new screen, whenever they are logging in with the new screen, the extension makes sure that the size of the screen is compatible. After the calibration is done, the user can freely move around the websites and see and browse around. Every time a WebGazer is started, there is a nudge that is shown which shows a camera in use nudge. Also, the eye emoji, which solely represents that the WebGazer is starting, can be hidden on the background and also scrolled across so that the user can see all the content on the screen at once. Let us fixate on a particular message. Let us look at the dashboard. The dashboard solely shows all the details. We got a nudge only once when the extension was at a phishing stage. So this is an important part of the extension, that the nudge is only shown when the risk detection shows a phishing text. So the dashboard shows all the requests and responses from the LLM and the source of the text. Let us go to the limitations. The limitations of this application is that the eye gaze accuracy when we are calibrating, it solely depends on the lighting around the room and the camera quality. The calibration required for the best performance. So if the user is not calibrating in the application properly, the nudges might not be as accurate. The model performance varies across writing styles. When a user is browsing throughout the browser, there are a lot of types of writings and the ways the data is presented. Sometimes many false positives can occur. Future enhancements for this application is integrating a fine-tuned LLM for more personalized experience rather than using an OpenAI key. Also, an on-device model upload or optimization can be provided. This gives the user a chance to go to the dashboard and upload their own AI model so that the extension is more privacy protected and no third-party LLM is used. Also, a multi-language phishing detection can be applied for a more broader users. A personalized risk threshold per user can also be shown on the dashboard, which can be assessed by some algorithm showing how much the user is looking at phishing texts. That is all from my side. Thank you.